Okay guys, we're going to go ahead and start going over your test review. Okay, starting with number 1, it asks us the 4 major stages of the scientific method are, and the correct answer should be A. It is observing, formulating a hypothesis, testing that hypothesis, and theorizing. Okay, number 2, it says by making several measurements with the same balance, a chemist obtains values of 5.224, 5.235, and 5.259 for the mass of a sample. Without knowing the actual mass, so we don't know the actual mass of the sample, we can tell that these measurements are, and the correct answer should be C, poor precision, because they're not very close together. They're relatively far apart from each other, so they're very poorly precise. And we can't say that they're accurate because guess what? We don't know the actual mass. Okay, moving on to number 5. It says the measurements that has only non-significant zeros is, so we want the measurement that has no significant zeros. So we look over here, remember it's no, last left, yes, first right. So we have to ask ourselves, does it have a decimal? Well, in A we see no, it doesn't. So we go to the last non-zero digit, which is 6, and we count left. 1, 2, 3. Well, that means that that 0 is significant, so it can't be A. Okay, then we look at B. Does it have a decimal? Yes, it does. So we go yes, the first non-zero digit, count right. 1, 2, 3. So those zeros are significant, so it can't be B. So we look at C, and we go yes, it has a decimal. The first non-zero digit is 3, and count right. We go 1, 2. So that means that those zeros are not significant, so the correct answer should be C. Number 6, it says if some measurements agree closely but differ widely from the actual values, these measurements are, so they're very close together. That means that they are precise, but they're not accurate because they don't have the right answer, so the correct answer should be C. Number 7, it says if two quantities are directly proportional, when one quantity increases by 10%, the other, well, we're looking at directly proportional, and remember directly proportional means as one goes up, the other goes up. So if it increases by 10%, then the correct answer should be the other increases by 10% as well, which that is A. And number 8, it says in division and multiplication, the answer must not have more significant figures than, and the correct answer should be A number in the calculation with the fewest significant figures. Alright guys, moving on to number 9. Now in the instructions on 9 through 15, it says in each of the following measurements, name the quantity being measured. Okay, so the first one that we have is 22 seconds. Well, seconds we use to measure time. Okay, when we have 3.5 milligrams, remember that milligrams is a mass, because grams is a mass. Here we have grams per milliliter. That is always a density. Here, J, this one's not going to be on your test, but J stands for energy. It's joules. We have km. It's kilometers. So we're looking at meters, which is basically a length. Here with milliliters, anything with liters in it is going to be a volume. And then here we have a derived unit, which is meters squared, which meters squared is always a area. Alright guys, and 16 through 19 is asking us to identify the following data as qualitative or quantitative. Remember that qualitative is going to be a quality, meaning it's going to be a description, and quantitative is going to be a number. So in the first one it says that a solid dissolves in water. We don't see any numbers, so we know that that is qualitative. In 17 it says the temperature of a solution is 3 degrees Celsius. Well, we see a number there, so that one is going to be quantitative. Where it says the solution is dark blue, no numbers, so it's qualitative. And then the density of the solution is 1.13 grams per milliliter. We see a number, so therefore it is going to be quantitative. Alright guys, moving on to 20, talking about fill in the blank. Now, number 1, it says the speed of light is 300,000 kilometers a second. This number equals how many kilometers per second in scientific notation. So remember, all we do is move the decimal. So we're going to start here and move it 1, 2, 3, 4, 5 places. So our answer is going to be 3.0 times 10, and we moved it 5 places to the left, so it's going to be positive 5. And that's kilometers a second. Here it says the quantity 0.202 grams has blank significant figures. Remember, here we're talking about no, last, left, yes, first, right. Remember, we ask ourselves, does it have the decimal? If we say no, we go to the last non-zero digit and count left. If it does, meaning yes, it has a decimal, we go to the first and count right. So here, yes, it has a decimal. The first non-zero digit is going to be that 2, and all we do is count right. 1, 2, 3. This has 3 significant figures. Now 22, it says if 2 figures are significant, how should the measurement 0.0255 be reported? Okay, so what we have to look at here, we only want to round to 2 significant figures, so we got to figure out what's significant. We come here, yes, it has a decimal. The first non-zero digit is 2. We count right, 1, 2, 3. Now only 2 of those can be significant, so we need to round it up, and that will be 0.026 would be our answer. Okay, because we can only have 2 significant figures, so you just take the first 2. Moving on to 23, it says a Florence flask can obtain 250 milliliters of liquid. Expressed in scientific notation, the capacity of the flask in liters is, so we're changing the scientific notation here. We move the decimal over 1, 2 places, so it's going to be 2.5 times 10 to the second. Because we moved it to the left, it's positive. Now, number 24, it says a blank is something that has magnitude, size, and amount, and that's always quantity. Quantity is our answer for number 24. 25, it says the SI base unit can be combined to formed. When we multiply and divide SI base units, we get a derived unit. So the answer to 25 is the derived unit. Number 26, it says to change from one unit to another, you must first determine the appropriate. So if we're going from one unit to the other, we always use conversion factors. So the answer to 26 is conversion factors. Alright guys, moving on to using some conversion factors. First one, we're going to convert between kilograms and grams. Remember guys, anytime that we have conversion factors, we always have to write our statement of equality. Well, and I'm going to give you these on your test. I'm going to give you a conversion chart. We know that 1 kilogram is always going to equal 1,000 grams. Now we have kilograms and grams, and that's the things we have, and we have it in the statement of equality, so we don't need any more than that. So what we're going to do is take the number that it gives us, which is 43.2 grams, and set up our boxes. If grams is on top, we put grams on the bottom, so we're going to put 1,000 grams on the bottom, and we're going to put 1 kilogram on the top, and we're going to multiply the top, so 43.2 times 1, which is going to give us 43.2, all divided by our bottom. Remember, there's always an understood 1 there. 1 times 1,000, which is 1,000. We go ahead and we divide that out, and we're going to get an answer of 0.0432. Okay, moving on to our next one that we have milliliters and liters. Well, the first thing we have to do is write our statement of equality. We know that 1 liter is going to equal 1,000 milliliters. Okay, and from here we can go ahead, and since we have liters and milliliters in our statement of equality, we move on to working out the problem. We don't need any more. So we take our 5.4 liters and set up our boxes. If liters is on top, we put liters on the bottom, so 1 liter on the bottom, and then we put the rest of it on top, which is 1,000 milliliters. And we go ahead and we multiply the top. 5.4 times 1,000, all divided by 1 is going to give us right around 5400, 5400. Okay, moving on to the next one. Here we see that we have Kelvin and Celsius. So what we want to do is we're going to change it into Kelvin. Remember that Kelvin always equals our Celsius temperature plus 273. So we take our Kelvin, plug in our Celsius of 27 plus 273 is going to give us an answer of 300 Kelvin. And then our last one, we see that we are converting from joules to calories. And the good thing here is it gave us our statement of equality right here. So all we have to do is just work it out. We have 250 calories. Set that up. If calories are on top, we got to put calories on the bottom. We know that 1 calorie equals 4.184 joules. Okay, we multiply the top, which is 250, all times our 4.184, and all divided by 1, and we should get an answer of right around 1050 joules. Alright guys, moving on to 33. It says, how does weight differ from mass? Now remember that mass is the same no matter where we are, and weight depends on the gravitational force of the Earth. So the more gravity we have, the more weight we're going to have. So if we took our weight on Earth and then we took our weight on the moon, we would have different values, but our mass would always be the same. Weight depends on where you are in the universe. Mass is always the same. Now, 35, it says, describe the graphs of two quantities that are directly proportional and a graph of two quantities that are inversely proportional. Main things on these, remember that our graphs that we have, if we're looking at a direct proportionality, we're going to see a linear graph or a straight line. And if we see inversely proportional, we're always going to see a curved line, something that looks like that. So straight line is always going to be direct, curved line is always going to be inversely. Alright guys, moving on to 36. It says the mass of a 5 cubic centimeter sample of clay is 11 grams. What is the density of the clay? Now what we need to know here is we need to know the density equation. Density equals mass over volume. Okay, and we see that here we look at what our givens. Our givens are going to be 5 cubic centimeters and 11 grams. Okay, and then what we always going to do is plug that into our equation where we have density equals our mass, which is 11.0 grams, all divided by our volume of 5.00 cubic centimeters. And take those guys, and we go ahead and work those out, and we should get an answer of 2.20 grams per cubic centimeters. Okay, moving on to our next one that we have. It says a length measurement is 1.40 centimeters. The correct value is 1.36 centimeters. Calculate the percent error. Well, the percent error equation is going to be our accepted value minus our measured value all over our accepted value. And we're going to take that entire thing and times by 100. Okay, and we're going to take the absolute value of this. You can either do the absolute value at the top, or you can have a negative. Either way, it works out fine. So what we're going to do is take our accepted value, which is 1.36, minus our 1.40, all divided by our accepted value, which is 1.36. We're going to take that entire thing and multiply it by 100. And what we see happens here, remember, subtract first, then divide, then multiply by 100, and do each piece at a time. So do 1.36 minus 1.40, enter, divided by 1.36, enter, multiply all that by 100, and we should get a percentage of right around either negative 3%, or you could just put 3%. Either one would be fine with. Alright guys, moving on to 38. It says the density of lead is 11.35 grams per cubic centimeters. What is the mass of a 10 cubic centimeter piece of lead? So we're looking for mass in our equation. Remember, our equation is density equals mass over volume. Now to find this, what we always do, remember, put density over 1 equals mass over volume, and cross multiply here, and we get our mass, which equals density times volume. So all we have to do here is we take our mass equals, plug everything in, which our density is 11.35 grams per cubic centimeters, times our 10 cubic centimeters, and we should plug that into the calculator, and we should get an answer of 113.5 as our mass. Okay, main thing here, guys, remember our units. Cubic centimeters is the volume, and grams per cubic centimeters is a density, or it could be grams per milliliters of density as well. Here it says what is the volume in liters of a cube. That's the main thing here, cube, whose edge is 4.33 centimeters long. Well, we know that our volume is always going to be our length times width times height, or it's going to be, since this is a cube, all we have to do is take 4.33 and raise that to the third power, and we cube it, and we see that we would get an answer of 812, and that would be cubic centimeters, which is a volume, just length times width times height, or 4.33 cubed, or 4.33 times 4.33 times 4.33. Okay, moving on to number 40, it says what is the sum of, and it gives us 3.089 and 0.07452. Now on these, this one, it wants you to find the correct number of sig figs. So we're going to have 3.089, and then we're going to have 0.07452. Okay, and we set all that up, and we go ahead and we work this out, and we get a number of 3.16352. Okay, and the main thing here is, remember our rules that we have. If we're using multiplication or division, we use the least number of significant figures, but since here it's the sum, which means addition, we're adding, remember we use the least number of decimal places. So in looking at this, 3.089 has only 3 decimal places, so we have to round to 3 decimal places, so it's going to be 3.164, because that 5 is going to round that 3 up to a 4. Okay, remember, adding and subtracting least number of decimal places, multiplying or dividing, is the least number of significant figures. Guys, if you have any questions over anything, come see me in the morning and I will be happy to help.